All right, guys, we're going to look at some of our multiple choice questions. So number one is, of the following dot plots, which represents the set of data that has the greatest standard deviation? So what we're going to look for is we are going to look for the set of data that is furthest from the mean. All of these, A through E, are symmetrical, which means that my mean is going to be right here in the center. All right, so when we look at these, we want to see which set of data has the most points that are furthest from the mean. And if we look, we would notice that B, all of our points seem to be clustered near the endpoints, near 0 and 10. They have the furthest distance from the mean, which is going to give us the greatest standard deviation. If we look at question 2, we're looking at a box plot, and they're asking us to identify the IQR. So just as a reminder, IQR is Q3 minus Q1. Okay, and to find Q1 and Q3, all right, Q1 is going to be the starting edge of my box, and Q3 is going to be the end, the last edge of my box. And of course, right in between that, that is the median. Right, these endpoints, that's going to be my minimum. This is going to be my max, and this would be an outlier. So if we want to estimate our IQR, I'm going to come over here and I'm going to look at Q3 and I'm going to go straight across. And I'm going to say Q3 is, we're going to say about 19 minus, and then I'm going to come over here and I'm going to do the same thing for Q1. And I'm going to say Q1 is about 4. And so 19 minus 4 gives me 15. Okay, the approximate interquartile range, the IQR that's closest to 15 from my answer choices would be C, which is 16. If we look at 3, the histogram above shows the number of minutes needed by 45 students to finish playing a computer game. Which of the following statement is correct? The distribution is skewed to the right. Remember, the skew is the direction of the tail. So if I was to kind of draw a nice smooth curve over this, all right, my skew on this is not going to be to the right. My skew on this is going to be to the left. So we know A is not going to be the answer. If we look at the next option, it's skewed to the left. Well, we just talked about that one. This distribution is skewed to the left. All right, it does not appear to be normal. Normal would be that bell-shaped curve. The chi-squared distribution should be more of a right skew, which this is not. And the last one, this distribution appears to be uniform. If it was uniform, then for all of the x values, it would have the same frequency. It would have the same y value. They'd all be the same if it was uniform. So our answer is correct with B. If we look at question 4, it says a bank surveyed all of its 60 employees to determine the proportion who participate in volunteer activities. Which of the following statement is true? So right off the bat, guys, if you notice, it said all of its 60 employees. So this is a census, right? We don't have to take a sample to try to estimate the population because we have the population, right? So if we look at these answer choices, in this case, our answer is going to be E. The bank does not need to use an inference procedure to determine the proportion of employees who participates in volunteer activities because the survey was a census of all employees. If you look at D, it says the bank would have to use the survey data to construct a confidence interval. We build confidence intervals to estimate information about the population. Because we have all of the information from the population, there's no need to build a confidence interval. Same with C, it says the bank did not select a random sample of employees, so the survey will not provide the bank with useful information. We do random samples to try to eliminate bias, right, when we're trying to infer about a population. But once again, we have the whole population. So it doesn't matter that it wasn't a random sample. And then A and B are really geared towards experiments, which this wasn't, right? For B, the bank can use the results of this survey to prove that working for the bank causes employees to participate in volunteer activities. There was no treatment implemented, so there is no cause and effect, or we can't prove that working for the bank, right, working for the bank causes employees to participate in volunteer activities. And then for A, the bank should not use the data from the survey because this is an observational study. That's not correct either. You cannot find cause and effect with observational studies, but you can absolutely use data from observational studies. All right, question 5. The histogram below displays the frequencies of waiting times in minutes for 175 patients in a dentist office. Which of the following could be the median of the waiting times in minutes? So I went ahead and took the 175 patients and divided it by 2, and so our median would be at 87.5. So that means we would take the 87th piece of data and the 88th, and we would average them to find our median. So if we're trying to find the median based off of this histogram, we're going to look and see where 87.5 falls. So from 0 to 5 minutes, we have our first 80. All right, and so we know our median is not going to be between 0 and 5. 87.5 is going to fall in our second bin, all right, which is going to be between 5 and 10. So looking at our wait times, which one could possibly be the median? The only one that is between 5 and 10 is going to be B, which is 7.25. 6, data were collected on the amount in dollars that individual customers spent on dinner in an Italian restaurant. The quartiles for these data are given below. Which of the following statement must be true for these customers? All right, so one thing that we need to remember is Q1. If we were to look at a number line, all right, here's our minimum. Here's Q1, which is 25%, the bottom 25%. All right, Q2 is our median. And in between Q1 and Q2 is another 25%. Q3, all right, in between each of these are 25%, and then we end right here with our maximum. And that gives us our final 25%. So up here it says at least half the customers spent less than or equal to 44.27. So 44.27 is Q2, all right, which is our median, and it says at least half the customers spent less than or equal to. Less than or equal to is going to be to the left, all right, which this one happens to be true right off the bat. Our answer is actually A. All right, if we kept going though, 75% of the customers spent between 36.27 and 58.97. So they're saying that in between Q1 and Q3, that's 75% of our data. And if we look, we know that that is not. That is our IQR, which is the middle 50%. All right, so B is incorrect. C, 25% of the customers spent less than or equal to $58.97. All right, that's our Q3. And they are saying that 25% of the customers spent less than or equal to. So less than or equal to is everything to the left of that, which as we can see, that is 75%, not 25%. All right, the mean amount spent by customers is 44.27. We do not know that from here. We do know that the median is 44.27, but we do not know anything about the shape of this distribution. So as of right now, we do not know that the mean and median are equal. So we cannot say D. And then the last one, a majority of the customers spent $44.27. All right, that's saying right here, all right, that a majority of the customers spent $44.27, and we do not know that. That is not true. All right, we just know that the median is $44.27. All right, so E is not correct either. 7, the weight of an adult male grizzly bear living in the wild in the continental United States is approximately normal with a mean of 500 pounds and a standard deviation of 50. And this is for males. All right, the weight of an adult female grizzly bear is approximately normal with a mean of 300 pounds and a standard deviation of 40 pounds. All right, approximately what would be the weight of a female grizzly bear with the same standardized score as a male grizzly bear with a weight of 530 pounds? So I need to figure out what the z-score is going to be for a male grizzly bear who weighs 530 pounds. So I'm going to say z equals x, which is 530, minus the mean, which in this case is 500, divided by my standard deviation of 50, and I'm going to get that, and that z-score is going to be 0.6. So if we want to find out what a female grizzly bear's weight is with a z-score of 0.6, then what I'm going to do is I'm going to take that equation, I'm going to say 0.6, that's my z-score, equals x minus the mean for females is 300, and I'm going to divide it by the standard deviation for females. To solve for x, I'm going to take 0.6 and multiply it by 40, and when I do that, I end up with 24 equals x minus 300. And to get x by itself, I'm just going to add that 300, so I end up with 324 equals x. So the weight of a female grizzly bear that is 0.6 standard deviations above the mean is going to be 324 pounds. Now, you could have also used your calculator. We could have gone to menu, algebra, and we could have done solve, and we could have typed in the same equation. We could have said 0.6 equals, and I'm going to go ahead and hit Control Divide, x minus 300 divided by my standard deviation for the female grizzly is 40, and then we just tell the calculator what we want it to solve for. So I'm going to hit comma x, hit enter, and it also gives me 324. So don't forget about that nsolve feature you can use on your calculator as well. All right, so for question 8, it says the company sells concrete in batches of 5 cubic yards. The probability distribution of x, the number of cubic yards sold in a single order for concrete from this company, is shown in the table below. The expected value of the probability distribution of x is 19.25 and the standard deviation is 5.76. There is a fixed cost to deliver the concrete. The profit y in dollars for a particular order can be described by y equals 75x minus 100. What is the standard deviation of y? So for this one, guys, what they're looking at is to see if you remember that when we apply a linear transformation to data, right, when we multiply, for instance, multiplying by 75, like we have right here, right, that is going to change my spread. But when I add and subtract, like subtracting 100, that is not going to change my spread. So if they're asking me for my standard deviation, all I'm going to do is take 5.76, the original standard deviation, and I'm going to multiply that by 75, all right? But I am not going to subtract the 100 because adding and subtracting a constant does not change our spread. So when we do that, 75 times 5.76, we end up with 432. And so our answer for this one is going to be B, $432. Now, just as a reminder, if they had asked us for our mean or if they had asked us for the expected value, okay, our mean, then in that case, we would have multiplied by 75 and subtracted from 100. Okay, our centers change when we multiply, divide, add, or subtract, but our spread only changes when we multiply and divide. All right, our last problem for this video, based on a survey of a random sample of 900 adults in the United States, the journalist reports that 60% of the adults in the United States are in favor of increasing the minimum hourly wage. If the reported percent has a margin of error of 2.7 percentage points, which of the following is closest to the level of confidence? As a reminder, the margin of error formula is on your formula sheet, but our margin of error is our critical value times the square root of p hat times 1 minus p hat over n. So if we fill in what we know the margin of error is 0.027, that's that 2.7%. Okay, we don't know our critical value, but we can find our margin of error as 0.6 times 0.4 over 900, and we square root that. If we solve for z, we're going to divide out that square root of 0.6 times 0.4 over 900, and we end up with z equals 1.653. Now, if we want to find the confidence level, we can go to normal CDF, and we can do our lower bound of negative 1.653 and an upper bound of positive 1.653. Our mean and standard deviation are going to be 0, and we see that we get an area of 0.90. So 90% is going to be our answer for number 9.